Welcome to section 1.3. We're looking at linear functions. Linear, again, it contains the word line, so we're basically just looking at functions that are lines. So a linear function can be written in the form f of x equals ax plus b, where a and b are real numbers, and again, f of x is another way of writing y. It's just saying that it's a function. So if f of a equals 0, then the point a, 0 is called an x-intercept. We also call the a value the 0 of the function. For any linear equation, y equals ax plus b, to find the x-intercept, we let y equal 0 and solve for x. To find the y-intercept, we set x to 0 and solve for y. Example 1, graph the linear function f of x equals 2x minus 4, identify the intercepts, and 0 of the function, if they exist. Alright, so for graphing the function, so to graph the linear function, I'm going to go ahead and find the y-intercept, and using the form that we have here for slope-intercept form, we know that our y-intercept is negative 4. So that's going to be 0, negative 4. To find the x-intercept, we'll go ahead and set y equal to 0. So using our function above, remember f of x is the same thing as y, so we'll set that equal to 0, and that's just equal to 2x minus 4. And then solving for x, we'll add 4 to both sides, and we get 4 equals 2x, and divide both sides by 2. So 2 equals x. So our x-intercept is 2, 0. Let me go ahead and graph this in red. So x-intercept 2, 0. Sorry, my dog's walking around in the background. And then 0, negative 4 for y. 0 and negative 4. And one thing I do require for definitely on the final, you need to give at least 3 points for each line. So we need to find one more point. To do that, we'll use the slope. And the slope is always the value by the x when it's in slope-intercept form. So m equals 2. If I was to change that to the directions, that's the same as 2 over 1. So this means we go up 2 over 1. And from either point you pick. I'll pick this one. Up 2 over 1. And we found our other point. You could have also started from the x-intercept. And that point is 1, negative 2. And there we have the equation of our line. So do we have a 0 of the function? We do. The 0 of the function is our x-intercept, which is 2. So the 0 of the function is 2. All right, let's take a look at slope. So the slope m of the line passing through the points y, x sub 1, y sub 1. Oops, wrong. I thought that was the highlighter. X sub 1, y sub 1, and the other point, x sub 2, y sub 2, is given by the following. So we take the subtraction, and we get the change in y over the change in x. So the slope-intercept form of the equation is where we have y equals mx plus b, where 0b is the y-intercept and the m is the slope. All right, example 2, find the slope of the line passing through the points negative 2, negative 4th, and 5, half, then graph the line. All right, first let's go ahead and find m. M is going to equal, we have to take the subtraction between the y's and the subtraction between the x's. So I'll do the y's first, so that'll be a half minus negative 4th over negative 5 minus negative 2. So we have a half minus a 4th. I'll go ahead and change that to 4ths as well. That'll be 2 4ths plus 1 4th all over 5 plus 2, because we have that double negative, becomes a positive. 5 plus 2 is going to be negative 3. So it was a negative 5 plus 2. So negative 3. And then we have m equals 3 over 4 divided by negative 3. And we can simplify that out. M equals 3 over 4 divided by negative 3 over 1. To change to multiplication, we'll take the reciprocal. M equals 3 over 4 times negative 1 over 3. The 3's will cancel out, and we're left with m equals -1/4 as our slope. Okay, good. So we found the slope. Check. Now we have to graph the line. So we know the point -2/4. Let's see, -2, -4. It's going to be somewhere around here. Let me zoom in. So -2, -4. And then we have the slope -5/2. So -5.5. Oh, I think I graphed that one wrong. -2/4. The other way. -2 1/4. So to find another point, which would be really messy, because we have these messy little decimals, we'd pretty much need to count down 1 and over 4 from each of these points. So we could go ahead and do that. We'd go down 1, 2. Oh, there's down 1 over 4. I take that back. We're going to go down 1 and over 4. So that was down 1 and then over 4 units. Just waiting on my pen to load. So down 1 unit and then over 4. 1, 2, 3, 4. Again, notice they're all in these sort of fourth values because it's not a perfect item. So that is going to be at the point 2, comma, and we went down 1/4, -1/4. And that would be our other point. So it's easier to count if the numbers are nice whole numbers. It doesn't work the best to use the slope for counting when they're these nasty fractions that we have. But if that's all you have, that's all you have. Alrighty, so let's go ahead, connect the lines, do your best. If it's not perfect, that's okay. Please remember your arrowheads. Arrowheads are super important for the lines. Again, when I'm grading the work for the final exam, arrowheads important. Label 3 points for your line. Alright, let's take a look at example 3. Graph the line with a slope of m equals -2 and passing through the point -1, 1. Alright, with a slope of -2 and the point -1, 1. So the point -1, 1, we have x is -1 and y is 1. That's going to be here. -1, 1. And then we know our slope is -2. If I put this over 1, we can get our directions. We go down 2 units, positive 1 unit. So down 2 over 1. Let's go ahead and count that out. Down 2 units over 1. And we're at the point 0, -1. Let's do it one more time, because remember we need 3 points. Down 2 over 1. And we're at the point 1, -3. Okay, and we found all 3 points. Passing through, and we found the line passing through -1, 1. So we'll go ahead and graph that in. Again, you don't need to do a super straight line. Just give the basic concept. And again, I do grade for the 3 points and the arrowheads. All right, let's take a look at the next one. So we're asked to graph the linear function f of x equals -½ x plus 2. Identify any intercepts, state the domain, range, slope, and zero the function. So we got a lot of things. First off, let's go ahead and identify the easiest ones at the beginning, which, whenever it's in this form, is the slope and the y-intercept. So let's go ahead and do that. So you know that m equals -½ Got that down. My y-intercept is going to be 0, 2. Got that down. Now my x-intercept, how do we find that? Well, we set y to 0. That's going to go to 0. So we have 0 equals -½ x plus 2. Solving for x, we'll move the -2 to the other side. And then to get x by itself, we'll multiply by -2. And we get 4 equals x. So my x-intercept is 4, 0. Which would also be the 0 of my function. So the 0 of the function is 4. Now what else do we need to find? Oh, we need to find the domain and range. So first let's go ahead and graph this before we do domain and range. So the y is 0, 2 for my y-intercept. My x-intercept is 4, 0. And my slope is negative half over 2. So to find out how to get another point, because again I need 3, negative half over 2 is the same as going down 1, right 2. So let's go ahead and do that. Down 1, right 2, 1, 2, and we're at this point right here, which is 6, negative 1. Okay, awesome. Let's see. Go ahead and graph that. It's not going to be perfect, but it'll be what it'll be. Again, try to make it as straight as possible. And there we have the equation of our line. What else am I missing? We graphed it. We found both of the intercepts. Okay, we're missing domain and range. We've done everything else. So the domain, what is that talking about? Again, it's the values of the x's that we use. So if I read my problem, or my graph from left to right, which x values do I use? Well, I start at negative infinity up here, and then I continue on till positive infinity. So my domain is going to be negative infinity to positive infinity. Now for the range, we're talking about the x, or the y values. So that's looking at going this way, vertically. So if you look at our arrowheads, we're going down to the negatives and still up to the positives. So because of that, our range is also going to be negative infinity to positive infinity. And let me clean my graph up. Okay. All right, a lot of information to find on that one, but really good information to know. Okay, all right, let's go ahead. Actually, I want to fix that line. That's bothering me a little. There we go. Looks better. Okay, so let's take a look at example 5. Find the function represented by the graph. Okay, so we have to do the opposite now. We need to find the function, so f of x equals something. We could probably use mx plus b to find it. So to fill this out, we need to find a slope and a y-intercept. Do we have a slope and a y-intercept? Well, we could find it from here. This would be my y-intercept, whatever that is. And then I could pick any other random point on my line, for example, maybe the x-intercept, and count the rise of a run to find slope. Sounds like a good plan. Alrighty, go ahead, pause the video, try that out by yourself, and then check in with me. Okay, so hopefully you paused the video. I know my y-intercept is 0, 4. My x-intercept is negative 2, 0. So to find my slope, which is the only other thing I need, I just need to count up from one point to another. And I'm just choosing my intercepts. So I need to go up 2 values and run 1 value. So my slope, again, remember rise over run. I go up 2, positive 1. So my slope is technically just 2. So the equation of my line is going to be f of x equals, we'll replace m with 2 and b with 4. Because that's that there, and this is that. And then we have f of x equals 2x plus 4. And there we have the function represented by our graph. Now let's take a look at this part. A horizontal line is the graph of a linear constant function. Constant being because it never really changes. Let's take a look at y. Of the form f of x equals b, where b is a real number, the y-intercept is 0, comma b, and the slope is 0. Again, so careful, for a horizontal line, the slope is going to be 0. Now for a vertical line, which has the form x equals k, where k is a real number, and the x-intercept is k, comma 0, and the slope is, careful, undefined. So the slope for a vertical line is undefined. And careful here, vertical lines are not functions. The only lines that aren't functions. So example 6, graph the linear equations, identify any intercepts, state the domain and range, and use the slope formula to compute the slope. All right, so let's see. What are we given? Y equals negative 2. According to here, that would be a horizontal line. At what point? Well, negative 2. So that's going to be a horizontal line at the point -2, or y is -2, right there. Let me change that. Okay. Whoop, there we go. A little neater. So that is the point 0, -2. Again, we need 3 points. Pick any random points. I'll do 4, -2, and how about -4, -2. There we have our 3 points. What else do we need to do? We graphed it. Identify the intercepts. Okay. So for the y-intercept, do we have one? We do, right there. That's going to be 0, -2. How about x-intercepts? Does it ever cross the horizontal axis? It doesn't ever cross that, so we're not going to have any x-intercepts. So because we're not going to have any, we're going to write none when we don't have any. You wouldn't write 0 because 0 would look like it's a number. So again, we're going to write none if there are no x-intercepts, or vice versa if there are no y-intercepts. What else are we missing? We did the intercepts. Awesome. State the domain and range. So the domain, again, what x values are we using? We're going between -infinity all the way to +infinity. How about range? Range, again, we're talking about the numbers we use along the y. And we only use one number. We only use 4. Sorry, we only use -2. -2, -2, -2. It's never going to change. It's constant. Hence the name constant function. So because of that, the range goes from -2 to -2. And that is it. And lastly, what do we need to find? We need to find the slope. So use the slope formula to compute the slope. All right, so what is the slope formula? Again, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We need 2 points to fill this out. I actually have 3 on this, but let's just go ahead and pick any random 2. You could do it with either one you want. I'm going to go ahead and choose this one and this point. You could have chosen one of the other points as well. So let's see what we get. I'll do x sub 1, y sub 1, x sub 2, y sub 2. So that'll be -2 minus -2 all over 4 minus 0. And then that becomes -2 plus 2 over 4. And m equals 2 minus 2. Oh, that's a 0 in the numerator. And anything over, or anything that divides 0 is just going to be 0. So my slope is just 0. So the slope of a horizontal line is always going to be 0. Let's take a look at the next one. X equals 3. So again, what do we need to find? We need to find the intercepts. So the x-intercept, y-intercept. Then we need to find slope. And what else? Domain and range. And is that it? Yep. Okay, let's go ahead and graph this. So this is saying x equals 3, which means x is always going to be 3. There's no change to it. Again, a constant function, or a constant equation in this sense, because vertical lines are not functions. So whatever point I pick, x is always going to be a 3. That's what this equation is saying. So any of these points and any of the ones in between would be part of this equation, or the graph of this line. So again, I'll just pick 3 random points to label. 3, 4, 3, -4. And there we go. I have 3 points. Awesome. Next, we need to find if there's any x-intercepts. Do we have one? We do. I picked it. And usually I pick the intercepts if I can. So that'll be 3, 0. Do we have any y-intercepts? No, it never crosses the y. Let me change that color. It never crosses this. So because of that, we don't have any. And again, we're going to write none if we don't have any. And then what would my slope be? Well, let's go ahead and use the slope formula to, again, calculate slope. So I'll let these be my sub 1s, and I'll let these be my sub 2s. Feel free to pause the video and try this out by yourself and see what answer you get. So sub 2, let's see, -4 minus 0 all over 3 minus 3. So m is going to equal -4 over 0. Ooh, what is that? Anything divided by 0 is going to be undefined. So the slope of a vertical line is undefined. Very interesting. So let's take a look at the domain. What values do we use for the x? Well, we only use 3. That's the only number we use for x. So my domain is just going to be 3 to 3. And that's it, just at one point. So my range, what numbers do I use? I use all of these numbers from negative infinity to positive infinity. So that would be my range. Then I'll go ahead, box my answers. And we're done for that one. So let's move on to the last part in this video, which is slope as average rate of change. So the slope m, and again, this is the formula that we've seen before, is equal to the change in y over the change in x. This gives the average rate of change in y unit per change in x. The slope is used extensively when we wish to compare how one quantity changes with respect to another quantity. For example 7, the following graph represents a tank that is being filled with gas, where x represents time in minutes and y represents the volume of gas in the tank in gallons. So y is the volume, and what do we know? X is the time in minutes. Use the points to find and interpret the slope, or the average rate of change. All right, let's go ahead and do that. So we have m, and we just want to find the average rate of change. So let's go ahead and use the points they already give us here and here. That's going to be 3, 6 is one point we have. 3, 6, and the other point we have is 6, 12. So finding the average rate of change, we'll go ahead and take the change in those values. So if this is the sub 1s, I'll make these, let me check that. Sub 1s, this is the sub 2s. So we'll have 12 minus 6 over 6 minus 3. And m is going to equal 6 divided by 3, so m equals 2. So my slope is 2. And what does this mean in terms of this problem? Well, again, let's see. M is talking about the change in the y values over the change in the x. So the y values, we're talking about the volume of gas in the tank. So that's a volume of gas, and then x is the time. So as this increases by 2, the other one also increases by 1. And this again was volume of gas, and that was time in minutes. So you could say every minute every minute, what happens with the gas? It increases by 2 gallons. So the gas increases by 2 gallons. And there are other ways to write that sentence, but again, the main concept here is as the gas goes up 2 units, time goes up 1 unit. And that's the average rate of change. So let's take a look at example 8. Koala trees grow the fastest in the first 5 years. The following table represents the linear growth of a particular koa tree. The height, did I say koala tree? Anyways, we're talking about koa trees. So the height in feet was measured from the 2nd to the 5th year of the growth. Find and interpret the slope. So again, for slope, you could pick any 2 points and compare them. So I'm going to go ahead and go with this point and this point because they're the solid numbers. Don't have any fractions or decimals going on. So again, these are my x, these are my y. So the change in y, so we have 17 minus 8 over 4 minus 2. You could have picked different points. I just went ahead and picked these. So 17 minus 8, that's going to be 9. 4 minus 2 is going to be 2. All right, so what does this mean? Again, these are my height, and this is my year. So what do we know happens? Every 2 years, the height increases by 9 feet. The height goes up by 9 every time the year goes forward by 2. So we could say every 2 years, the trees grow by 9 feet. Okay, again, the unit was feet. We're talking about the koa trees and years. So the change in years was 2, the change in height was 9. So every 2 years, the height grows by 9 feet, or the height changes positively by 9. All right, example 9, last one. Active users on TikTok. In 2018, TikTok had about 55 million users worldwide. By 2022, the number rose to about 1,400 million, or 1.4 billion, users worldwide. Find the average rate of change of TikTok users worldwide from 2018 to 2022. All right, go ahead and pause this video and check your answer with mine. All right, so hopefully you tried to pause it and did it by yourself, but let's take a look. What are the pairs of information we have here? We're trying to figure out the comparison from 2018 to 2022. So I'm talking about years. So I know I have 2018 and 2022. What are the matching pair for the number of people? So for users, in 2018 we had 55 million. We'll just stick with 55. And in 2022 we had 1,400. Careful not to use the 1.4 because that would be a different unit with the million and billion. You got to stick to the same unit. So yours is in millions. So here we have the 2 points we're going to use. So let's go ahead and use that to find the slope. I'll do x sub 1, y sub 1, x sub 2, y sub 2. Plugging that in, we have 1,400 minus 55 all over 2022 minus 2018. And what do we get? About 1,345 over 4. Well, go ahead and stick like this, not the decimal. It's easier to read it if it's in a fraction form, not in a decimal form. So again, the y values are talking about the users in millions. And the x values are talking about the years. The number of years. So these are both positive. So as the years increase by 4, the users increase by 1,345. And again, million users. So let's go ahead and write that down. Every 4 years, what happens? The TikTok users increase, because again, this was all positive slope, increase by 13,045. And what unit? Million users. Alrighty, and if you wanted to change to billion, you could. Just be careful. If you want to use billions, both of the units, both of these y values would need to be in terms of billions, so be careful about your units. Alrighty, that is it for this video. Again, if you have any questions, feel free to email me. Other than that, good luck on the homework.